Hello Internet, welcome to our new app we're going to be working on. It's a universal Windows platform app, and we're going to be calling it our binary clock app. So if you're not familiar with a binary clock, it's a binary representation of the current time, and it's done in sort of like, we're going to be using probably squares to represent that. And so every digit in the time is used to represent, or is represented in binary, and that's displayed as the time. So what I'm thinking is we can develop a live tile that will show the time, and we can actually update that periodically. And then we can also do some other fun things. So there's a color-based time as well, which is going to be based off, it's going to use that binary, we're going to convert it actually into hex, and then from that hex we're going to create a color. Don't know how that's going to work yet. Still trying to figure that out, but that's what we're going to start with, because then we can start with something. I don't know. Didn't really plan this out. I just thought it'd be fun. So that's what we're going to do. So we have a super basic binary clock. This is just a basic universal Windows platform blank app. It's straight from the template. Nothing. I haven't added anything. So what we're going to do first is we're going to add a view model once it decides to respond. There we go. So if we do a new view models folder, then what we can do is we can add in a new, let's do, I hate doing this. Let's do a main view model. We can rename this later, but for now this will work. And so I'm going to make that public, and all it's going to have is just going to be a color. Public color. That's not what I want to do. We're going to make this private, actually. So our color is private, and then we're also going to expose a public color that is our background color, like so. And our private variable is going to be named the same thing. I like to distinguish my properties and my variables from themselves by just making one capitalized and one not. Some people will put like an underscore. I don't do that because I think that doesn't really help, and it doesn't really make anything cleaner. So that's what we're gonna do. Then I'm just gonna throw some quick getters and setters on here. Normally, if you just do like a get and a set like this, you don't actually need this private. It will be implicitly there. The compiler will do it for you. We're going to need it because we are going to do a little bit more. So I'm going to return the background color here, like that. And then in our set, we are going to have a little bit more fun. And I actually don't need that. Never mind. We'll get to that in a second, because what I need is I notify property changed. So it's actually been a while. I haven't touched UWP since we worked on Emotable. So we'll see how this goes. But what you do is you implement a iNotify property changed interface. This is just a standard interface that's part of WPF and UWP and Windows Phone and all of those platforms. If you are using a UI and you need to update, you use this to say, I have a property that changes, and it notifies people that it changed. And so what that does is it creates a new property changed event. And then this interface is letting other people know that you have a property changed event that they can subscribe to and actually use. So what we want to do now is we want to actually check if our property changed is not null, then we are going to invoke it with our sender, I think, which will be this, or our current object is the sender. And the new property changed event args are going to be that with a name of background color. And so that is a new-ish I think it's C#6 feature, which is going to grab the name of whatever property or class or whatever you give it, and then it's just going to convert this. So instead of that, we would get pretty much a string that says that. And so when you do a name of, it gives you a few extra things, because if we just wrote out the string, if you tried to rename this using any of Visual Studio's tools, it wouldn't detect that. Some tools were smart enough to do it. If it wasn't, you'd be kind of screwed. So this kind of helps there. So if you use name of, every refactoring tool you use is going to be able to detect this and use it. Here we have this question mark, and it's just pretty much saying, if this isn't null, then do whatever is after this. So it's like a conditional call. So you can chain these and do whatever you want, but all I'm saying is if our property changed isn't null, and it will be null if there's no events or nothing has subscribed to it. So if nothing's listening to it, that will be null, and we'd throw an exception if we tried to just invoke on it. So that's why you need to do that. And then the getter, there's nothing special there. It's just returning the value. The only other thing we need is if our background color is not equal to the value. So this is going to be if it's changed, then we want to do this. And we also, before we let everybody know that we updated it, we actually need to update it. So I'm going to take the value that is being passed into our setter and actually set our background color. So all this is doing is it's creating a really simple background color and then letting other things listen to the change. So if we change the background color, it's actually going to notice. So now that we have that, let's actually throw it into our main page. And just for testing's sake, I'm going to create a color from ARBG. And we're going to do 255. That's not how you do that. Can I just... The answer is yes. So C# can automatically convert bytes, or from ints into bytes, which these are integer types. It's going to take that and then it's going to automatically cast that down to a byte. So a byte has, usually a byte is going to have 8 bits, so 8 little ones or zeros. And then a int is usually going to have 32. I say usually because it changes. It's less of an issue in C#, but if you're working with C++, for example, the number of bits in a byte can change. Some systems had it as 7, for example. I don't. That was just the way it was. The standards haven't been standards forever. So we're gonna go with this, and I'm just gonna do a quick red. So it'll be completely opaque and it will be completely red, and that should be that. Then all we're going to do is we're going to try to bind the background of our app, which is right here. So right now it's just this white page, which is kind of awful. So once it loads, you just get this. And that's our app. What I want to do is I want to bind that brush that we just created to this background. And so how we're going to do that is we are going to take our main page, and I'm actually going to use the code behind, I think. And I'm going to take the data context. And so the data context in a WPF or UWP project is going to be, it's going to be where the data is coming from that you're referencing. It's kind of, if you're familiar with Angular, it's going to be like the scope. So if we set the data context equal to a new main view model, what we're telling it, hitting all the wrong buttons. What we're telling it is we're saying this object, this main page, has a data context of the main view model, which means everything in this main page can now see this main view model. This isn't the best way to expose it. There's other ways. We can expose it directly from the XAML, which we'll get to shortly. but this is probably the fastest. And so all this is saying is you can see these things. Specifically, you can see the background color. So now if we open up our main page, we'll see what's actually going on. I can close this little bottom bit a bit. And then you'll get a split view. It's going to have a designer up here, which is going to demo or preview our app. Right now it's defaulting to a phone screen. It's a universal Windows platform app. So this is going to work on phones. It's going to work on an Xbox. It's going to work everywhere. So we can kind of browse through these. We can look at, like, if I want to run it on a Pi, for example, a Raspberry Pi, we can see that. If we want to run it on Hololens, it'll run there too. There's a whole bunch of things, and you can kind of see the whole list here. So we've got all of that. And then what you can see down here is we have a grid with a background, which is just looking at our application. Sorry, it's looking at our application page background theme brush, which is a theme resource, which is a whole bunch of words that pretty much means there's a theme to your app, which is going to be, so you have an accent color, mine is like blue, and you also have a context, or like a, what's the best way to describe it? It's kind of a, so you can make it white or black, I guess is the, there's got to be a better word for it than that. Anyway, you can make your Windows theme either dark or light. And so that also is part of your theme. And what it does is it sort of defines how the applications look. And you can also override that here in your app.xaml. You can see there's a requested theme, which I think we can change or just remove. Requested theme can be dark or light. If I change it to dark, if I restart this application, since the theme resources changed, it should have a black background now, because we're saying we want it to be a dark application. So use the dark theme. When you use a theme resource, those are actually bound to the changes in the OS. So if somebody goes and edits it and then reopens your app, it will detect that. And it will detect that at runtime too, so it will automatically refresh those. So theoretically, if we didn't have this requested theme, it would just use your default. And then if you went and changed that default while the app was open, all of the theme resources would get refreshed. So if somebody changes their accent color from like blue to gold, for example, your app would change with that. And that isn't necessarily true for everything. There's static resources, which is going to do the same thing. You can see I can look up the same thing, but a static resource is built at at compile time, not compile time, but when you actually open your application, it initializes that and it stays the same throughout the application. So a static resource won't change, a theme resource will. And that's about all we need to care about there, because we're not really going to use it that much. I just figured it was worth covering. So what we do need is we need a page and we need resources. And so what I'm doing is I'm declaring that this page has resources, and we need to create a solid color brush, and I'll give it a key and call it our background brush. And we can give it a name as well and call it the background brush there. The name is what it's actually going to be named. If you don't give this, it kind of figures something out. But it's actually so how XAML works is it's actually compiled down into C# code behind the scenes. And it's actually used to define pretty much everything. So when you give something a name like this, you're actually giving it a usable name, which means now that it has a name, I could go in here and say backgroundbrush.color, for example. You can actually assign things that way. And that's because of the name. Since it has a key, it can be referenced here, which means that I can do say a static resource of our background brush, which is coming straight from here. So all we did is we created a reference to this resource, and then we're saying reference that and use it here. So now our background is assigned to that background brush, but our background brush doesn't have anything. So it's not really useful, really. But what we can do then is we can do and give it a binding. And so a binding is going to say, remember the data context we were setting? We can actually use that. So our data context is going to be this main view model. We've got a background color here. And so I want to take that and actually reference it and say, oops, and say the color of our solid color brush is equal to our background color. And so whatever is bound as the data context here, and there can be, you can have multiple data contexts within it. So I could, for example, have a data context here or anywhere else, and it's exclusive, so you can only have one per. It doesn't stack. So what we're doing is we're saying, since we assigned the page to have that main view model as the data context, that means that that color is available here and we can actually reference it. So theoretically, if I start this, our solid color brush should be assigned to our background, and our background color should be pulled out of our main view model. So our background should be red. But it's been a while since I've done this, and I'm kind of wondering if it's not going to happen. We'll see. There we go. So we've got a red background. So now that we have that, let's actually modify this a little bit. Let's play around with it. So we already had all of this fun work we did for this property change thing. So what I'm going to do is I'm actually going to, let's modify this in real time actually. So we have this data context with this main view model. That's cool and all, but let's get creative. So if we do a main view model, and we'll just call it our view model is equal to a new main view model, sure. And we'll set our reference to our data context as that. Then what I want to do is I want to also create a task that is going to be, oops, let's create a task, and this is going to be our color update task. It doesn't need to be assigned yet. What we want is we want our color equal to begin color update on our view model. So this is just going to be an async task that we're never going to stop. It doesn't need to stop. It's just going to be a task we fire off, and it will just keep going in the background. And what we can have it do is we can have it actually update the main view model's color. So we're going to stick two things in here. We're actually going to make this async, because this way we can use awaits. And then we'll just make it a while true, because infinite loops are the best, I guess. And then what we can do is we can stick a task.delay, and we're going to delay for let's say 50 milliseconds, so that will give us 200 update. No, that'll give us 20 updates, because 20 times 50 is 1000, so that'll give, yeah. So if we wait for that, and then after we're done with that, we can do a fun, we're going to need to update our color. And so we want our view model, background color, and let's do color from RGB. And how do we want to do this? We probably could, now that I'm thinking about it, we probably could do something smart, but I'm not going to. I'm going to do a math sign of our iterations, which is going to be int iterations equal to 0. And we're going to do plug in our iterations there. And we're just going to stick with red for now, because this isn't going to be final. And then what we can do is nothing else. All we have to do is increase our iterations by 1. And so this iterations is just going to count up, and then our sign is going to be based off of that. And I believe it returns a double, and we are going to want a byte out of that, which means we're going to want 128 plus that. Oh geez, how do we want to do this? So our sign is actually going to be between -1 and 1. We want that between 0 and 255. Which means if we do 128 plus our math sign times 128, I think that works. Let's do 100. Actually, 127 will definitely work. And then we need to cast this to an int. And it's still not going to like that because we're working a ton with ints, and we need it all to eventually end up as a byte. Yeah. Don't ever do this. This is bad. Why did I? Okay. So yeah. Yep. Okay. This sucks, but it's fine. We're fine. It'll work. It'll probably go pretty fast because our iterations are ints, which means that it's going to be fast. I'm gonna actually just add a really slow scale, so it'll not slows, but it'll slow it down a little bit. So we'll do 1,000 or 100th there, and so after 100 iterations, it'll go to 1 and so forth, which should be a few seconds. We should see a noticeable change. That's what we should see, and if we don't, then something awful has happened. So what I can do is I can actually start this, and everything should go. I'm expecting an error, and we'll get to that once that happens. Or nothing will happen. That's more interesting. Background color? Huh. I was expecting it to blow up in my face, but it didn't. Which is good, I guess. Why didn't it explode? That's kind of boring. All right. It broke in a way that I wasn't anticipating. That's all right. We can figure out what's going on. So we have our view model, and if we look at our data context, it should also have that. It does. The reason it does is because it's using a reference. So both of them are attached to this view model here, and that view model is an object type, which means, or it's an object type, so it's actually going to be used as a reference, which means that this data context and what we're referencing in this loop are both the same reference. The advantage of that is that we can change it here, and it gets reflected in our data context. That's pretty much it. What else? Something's broke. Yes, bad. But why? Why is it broken? I don't know. This is a good question, because we have our sign, times 127, so it should go between negative 127 and 127. I think we're just getting really big values, which might mean I'm going to take out that scale there, and we should see it kind of flicker, if I'm correct. Let's actually remove the breakpoint and just start it. This is even more confusing. What's going on? Losing my mind. I do not know. What the heck? Huh? Okay, that was weird. Okay, but it is working. We saw that it returned 0.7 and then negative 0.2. So we are getting consistent values. I can see what our sign is returning, and it seems to be correct-ish. We're just not updating, which makes me think this is wrong. So we got here, our background color is equal to 0A. Our value is different. So we get in there, we do that, and then we fire off that. I don't know what's going on. And yeah. This was supposed to be the easy part. Well, the whole thing was supposed to be easy. It was just supposed to be cool. Everything always breaks up. Oh, dang it. Okay, I'm pretty sure our update is broken. I think that's what's happening. So, how do we test that? We do something special. So I was expecting it to blow up in my face. It didn't, which was weird, which means this probably isn't working. So we're going to go back to the old school and try this. I don't know why this wouldn't work, or why this would cause an issue. It should be fine, but if in the case that it is the issue, we'll know. Okay, we are calling it, so that's good. So that gets fired off. But it doesn't seem to make a difference. Which is a problem, because it means things are broken and they're not supposed to be broken. And we know our colors are being different because we saw they were supposed to be different. So I'm thinking something else is messed up. So we are going to do things the hard way and see what happens. We're going to do a grid background here, and we are going to do a solid color brush like this. Now there's no difference between this and using the reference, except this way we aren't using the reference. And I'm wondering if the solid color brush was breaking it. if the static reference to it was causing the issue. If it was, this should fix it. I don't think so. Well, what the heck? Why are you broke? That's not helpful. Grid. Well, larg. It's not working. Frustration. All right, we're going to change one more thing. I am going to set our background color equal to 0 there, and then we're going to make it blue initially. And this way, at least we'll know, is it setting it at least once? No. Since it's staying blue and our async task is updating it, we know something else is happening. So I'm wondering if what I thought was going to happen is still happening. It's just being silent for some reason. And so what I was thinking was going to happen is you can't actually update the UI on a separate thread, which is what this would do. Since we're off, actually, no, that's the problem. What am I thinking? Duh, this doesn't work. So we need to return a task.run of this. Because we want this to run asynchronously. I was just running it normally. That doesn't actually work. But if we do this, then we get a task that's going to run and infinitely loop over this. And that should actually do it. We weren't getting any errors because we were updating our background, but we were also in an infinite loop, so it was never actually updating our UI. I probably should have caught that ages ago, but I didn't. Oops. So we have, this should work now. What we have is we have an actual async task. This will run in the background, and it will 20 times a second. It's going to update the background color to a different color of red, and this should actually do what we were hoping it would actually do. Or I could have just said a bunch of stuff and nothing actually changed. That's weird. Huh. Okay. Well, let's continue onwards, because that wasn't actually what I intended to do. There's a dispatcher on your pages, I guess is the way to, what the word they call it. And so a main page has a dispatcher, which is actually the main thread. It references the main thread. And so if you're running something on a separate thread and you need to actually like update the UI, for example, say you have like a dialog and you have like a progress bar and it's some async operation and you've got the progress bar going across and you need to update like text or progress or something like that. You can't do that in a separate thread. You have to get to the main thread and then update it. And so a dispatcher lets you do that. And so the way you do it is you just run something asynchronously, and we are going to do that with a run async with a normal priority, and we just want to invoke that. And then we just want to await it, and that way things won't continue until it's done. So it's going to wait, and then it's going to fire this off, and then it's going to increment our iterations, and then it's going to wait, and it's going to fire it off again, and keep going. So theoretically, now it should do something more intelligent. Please? No? Why? Why? All right. if it's not going to cooperate, I think we can coax it. And so the way we can do that is do a public solid color brush, and we'll just call it the background brush. And if this looks exactly like the actual name of that thing we were using, that's because it is. Because we're going to actually create one. And so I'm just going to return a new solid color brush with the color of our background brush. Like that. Or a background color, sorry. So what we can do with this is then we can stick a notify changed thing, and we're going to update our background brush as well. So we're saying our background color changed and our background brush changed, and that's because there's dependencies here. And now the interesting thing of the way XAML and all of that fun stuff handles this is this still isn't optimal, but we're not going to be calling this getter every single frame because we only redraw it once. So we're going to get it and then we're going to just use it, and then it will be used, I guess, until you update it and it sees an update. So theoretically, we should be able to now reference this using a binding in here. The actual issue is going to be something super simple that I'm going to smack myself in the face with after I go through and edit this. It's going to be like, you forgot like a semicolon, or that shouldn't have been there, or something equally silly. But for now, if we reference the background brush like this, when we update our background color, the background brush should update, I think. And so, huzzah! It actually works. So the bindings were, or the resources and all of that fun stuff was causing issues. That probably could cause a seizure. So we're gonna close that for a second and slow things down a bit. So if I make it at 100th the speed, we can actually see something interesting happen. And so it will slowly get redder, and then it will slowly fade back out. And so that all of this is happening because our notify property changed is saying, hey, I updated, and then it's telling it to redraw this because it's referencing it. So I think the next thing we're going to do is quickly, we're going to plug in some random other colors. So everything here is fine. The only other thing I want to do is kind of, first off, mess with the phasing of it a bit. And then second off, add different frequencies. And so by doing that, hopefully, we'll get a little bit different. And so we should get all three colors now. And it should be kind of a mix. So it'd start like a, I don't know, robin's egg blue. And now it's fading into like a pinkish. And it will just keep going through these colors. So the idea is eventually we'll be able to actually tie this into the time and use the time to calculate these colors. And then do something similar with this. And so instead of just randomly fading, the color will actually represent, based on the date and the time, it will actually represent something. And then we can stick our actual UI in front of that. But for now, I think this is probably a good place to stop, and we'll actually get into doing all the other cool stuff in the next video. So if there's anything you guys want to see, let me know. I'm really interested. If there's anything you guys want me to improve on, I'd like to hear that as well, because I'm still learning. So if there's something you guys want, or feedback you want to give, don't hold back. I think I can probably take it. If not, then oh well. So until next time, see you, Internet.